Started recording. So, the first section, as I said earlier, this is going to be the section that's important because if you can't do this, you will literally fail. You cannot do the rest of the test. Next one, JH, based off my theta. JH is my what?
JH is op.
Good. It is your opposite. Now, GH, which is across of the right angle, should clearly be our
hypotenuse.
excellent. And then what's left over, or you could think of it as next to the theta, JG, is going to be our adjacent. Okay? So if you cannot label these things, it is impossible to pass the test. Second thing that makes it impossible to pass the test, excellent, is not having a calculators. The reason I even put these questions here is to test if you know how to type into your calculator. Now, there's two things you have to make sure your calculator is. First, working. Second, it is in degrees. If you haven't changed it since the last time, it should stay in degrees. To check if it's in degrees, you click the mode button. On the third option, it says radiant degrees. You want to make sure you go right to degree.
I lost my calculator.
Press enter and make sure your degrees are highlighted. Then second, quit. Again, you want to check mode, click mode. And then once you're finished with mode, you click second mode to get out.
Second, wait, no, how do you get to it? Can you repeat that process?
Mode, 3 down, or 2 down, I guess. And then it should be radiant or degree. Make sure degree is highlighted.
Degrees highlighted.
And then you just click second mode to leave it. Or you could turn it off and turn it on again. All right.
And now it's already on that? It's already on that? So I do something, it's going to be doing with that thing?
That's the theta. What's up? Okay, so what we're going to do for each question is literally plug it into the calculator.
Wait, can you put on this test, like, what like, which formula, like...
SOHCAHTOA? No.
Why? It's
No,
so
I'm
easy
saying,
to remember.
right now, can you just do it? Just
Oh, sure. So it's
I
so.
lost my calculator.
Go ahead. If you don't have a calculator on test day, you could always borrow one from the front office. You just trade in your phone. Please, if you do that, though, show me the calculator so I can put it in the right mode. It usually is defaulted to radian. All right, so SOHCAHTOA is the code word. I will not be giving you that on the test.
You're not giving it to us?
SOHCAHTOA? No, you should know that. What? Yes.
Oh, it's so good,
So, first one, sine, you plug it in, is 0.81. So 0.81.
You can tell sine's 1 over what?
What?
Sine is 1 over
Opposite over hypotenuse. Tan of negative 30, you click tan, negative 30, negative 0.58,
What number are we on?
number 5. Now you have cosine of theta equals 6, 7. You need to get rid of cosine. Probably. I'm just not going to spend time fixing it, though. Trust it. So cosine of negative 1, I have to do on both sides to get rid of this cosine. So cosine negative 1, which means in this situation, theta is cosine negative 1 of 6 over 7. So what I'm typing into my calculator is second cosine, to guess cosine negative 1, 6 over 7.
How do you do negative cosine?
Second cosine. Blue button, second cosine.
We just put 31. Do what?
Yes, 31.
Divided by 7.
Mm-hmm.
I don't even know where's the divide by.
And this one.
I need to buy you do sin 125.
Use tan negative 1, cross that out. Theta equals tan negative 1, 4 over 3. So your answer is, that was 31. 33.1? 53? All right, I'm going to plug it in just for the video, okay?
0.81.
What?
53.1. You're not going to lose points, but you technically should put degrees on it, okay? Because those are angles.
Wait, whenever there's that 0 at the line through means negative?
No, that is a theta, which is a symbol for angles.
that?
So you're looking for an angle.
So wait, how do I know to put a negative or not?
The negative 1 is because cosine normal is on the theta, right? The normal cosine is on the variable, right? So I got to get rid of the cosine away from it.
Does that mean whenever there's that zero with the line through it, so I have to put.
It could be an X inside though. It could be any number or variable, I should say. Because your variable is in a normal cosine. So to get rid of the normal cosine, you have to do the opposite cosine.
I don't get that out. Is there like a way to draw that out to explain that?
Oh, shouldn't the first one be 82 because it's 81 9, so then you do 82.
IL. What would you do to get rid of the 3?
Multiply by x.
Good. What?
By 3.
Yes. All right. How will you get rid of the cosine?
Is it the Minecraft?
Multiply by code.
No. You have to multiply, or you have to do, it's technically not multiplying, but it's cosine -1. That's the opposites of each other. The same way division is the opposite of multiplication. Same way addition is the opposite of subtraction.
Maybe don't do that for the first one, like sine.
Because that's just inside the thing. It's literally not equal anything.
Oh, okay.
That's not a variable.
Okay, got it.
All right. Julie, do you have a question earlier?
Yeah, I don't know how you do that.
What do you mean do that?
But like 5 and 6.
You type it in your calculator. Look at this. I typed it in my calculator.
Why did you do negative 1?
Because you got to get the theta by itself. It's a variable. Sorry about that. All right. Next one. Give the trig ratio. So this is also basics. Basically, if I say sine of A, this test if you know what SOHCAHTOA means. So sine of A, so I'm at A in this case because it says sine of A. I want opposite over hypotenuse. So the opposite in that case is 12 over the hypotenuse, which is in 13. So for this one, you're just writing 12 over 13. This is testing if you know SOHCAHTOA. Cosine of A. So cosine is ka, or adjacent over hypotenuse. So 5 over 13. Tan is opposite, toa, opposite over adjacent. So that's 12 over 5. Next one, sine H. You have to look carefully. I said sine H. So from H is opposite over hypotenuse, which is 4 over 5. In this one, I say tan G. So opposite of G, guys, be quiet. Opposite of G now, we're talking about G here, is opposite over adjacent. The opposite of G over here, 3 over 4. Adjacent's 4 in this case. Cosine of H is adjacent, 3 over hypotenuse, 5. So you have to look at the letters in here to tell you where you're standing in the room. So make sure you read carefully. I remember 2 years ago, people made that mistake. What? It is when. So what? Sin is so. Yes, there's.
Why is it called sin?
Sin is the official word. So is the way to help us remember it.
Because the last two is like, oh, so is
So is opposite over hypotenuse. So we say so to help us remember is opposite over hypotenuse. All right, this one. Use the trig functions to find the missing side. So I had to set it up with my trig ratio. I know A is 63, so I'm forced to use A in this case. This one, I have to identify as the opposite. And this one, I have to identify as the hypotenuse. Wait a second, I have opposite and hypotenuse, so I'm using SOHCAHTOA reverse way to figure out opposite hypotenuse. That must mean I'm using sine. So sine of 63 equals opposite x over hypotenuse 9. My issue is I want to solve for x. I have to multiply on both sides. What number? 9.
Sine because it's 63.
63 and 90. You can just subtract 9. What?
I'm just asking for x in this one.
How do you know that's the formula?
Oh, not the angle?
Why is that
No,
the
no.
formula x over 9?
Because it's opposite over.
Yeah, how do you know it's opposite over 9?
Because you have 63 here, and you know SOHCAHTOA is so opposite over hypotenuse. So you first identify what you have. opposite hypotenuse, then choose the trig after
Wait, why are you multiplying it by 9? Oh, you multiply by 9 to get rid of x?
to get rid of the 9 from x. Yeah. So then you literally need to pull out your calculator. 9 times sine 63, which is just 8.
8.01.
So you could just put 8 or 8.0. I'm never going to be upset with more decimal points. Okay? Next one. You have angle 42. Angle 42 at T. From 42, you have a opposite,
Which is 12.
and then you have a, or you're looking for x, adjacent, which is x. Talking to me? Okay, so it's not talking. So, opposite and adjacent. SOHCAHTOA, which one is it? If we have opposite and adjacent, O and A. TOA, so tan. So tangent of 42 equals opposite 12 over adjacent x. So in this case, what I could do is swap positions with tan 42 and x. Or you could cross multiply and solve for it. I just say swap positions because that's quicker.
What's that, over L?
Over 1.
So is that where x equals 10, 42?
Almost. It's x equals 12 over tan 42.
Okay, but Jason is
X.
Tan, if tan is opposite over adjacent, why is it 12? Where do you get 12?
I'm gonna fail this part of the test.
Oh,
Yeah,
12 is the opposite?
Yeah, you got to identify your sides first before you decide what you're
This
doing.
part of the test is just, it's so confusing to me.
Why is it so confusing? I'm surprised about that.
The fractions is just so confusing.
No, you just literally swap the position with the x and the tan. That's all.
I just don't know when to swap it and when to multiply instead.
Wait, so is it 12?
Oh, that's a good question, actually. So what decides what they do? In this case, the x is on top. So to get rid of the 9 is really easy. I just multiply 9 on both sides. The problem here is, I'm going to do it in red. What you would actually, like the long way to doing it, is you would cross multiply. So you get 12 equals x tan 42. Then you would have to divide both sides, tan 42 on one side, tan 42 on the other side.
That's what we're doing right now.
That's technically what you're doing right now, which means your final result will look like what we have down here, 12 over tan 42. I'm saying when you have x on the bottom, just swap them, save yourself time instead of doing all the work, because it will result in the same thing every time. Based off what's given. So I will say 42.
So it's based off the angle it's given. I mean the degree.
Is recorded.
No, what if there's no degree?
What?
What if there's no degree? So you don't know how to determine what's adjacent or opposite.
If there's no degree.
There's always going to be a degree.
Yeah, or you have to choose what your degree is. Let's go through all the questions and maybe that'll answer your thing. All right. Sammy, do you feel like you understand a little bit more though, like why you do?
On this one, everything else I'm perfectly fine with.
Is it 10.8? Is that
That's the one that's just a little confusing.
Oh, I hear you.
But I'll study it.
So 12 divided by tan 42.
Why is it divided and not multiplied?
So in the red, I cross multiplied, right, Al?
Oh, I don't get it. Wait. What's the difference between this one and the one before?
Okay, before it was x over 9, which means what I do on both sides is multiply by 9 on both sides. Solves my problem, x is by itself, I'm happy. This situation, x is on the bottom, so I have to
Why can't you just put x over 12? Oh, because it's opposite.
I have to follow the rule. Yeah, I have to follow the code.
How do you plug that in?
Oh, so I do 12 divided by tan 42. 12 divided by tan 42 looks like 13.3. So if your x is
12 divided by
tan 42.
Oh, 42. Why not 40?
Guys in the middle, please cut it out. All right. Next page. This one, I'm missing my angle. Maybe this is what you were talking about. I'm not sure. But this case, I want angle A. I'm looking for angle A. I have this 7, based off angle A, what is 7?
Adjacent.
Good. And based off angle A, what is 9? Hypotenuse. Good. So now I use SOHCAHTOA in my head. SOHCAHTOA. So is cosine. Good. Because it's ka. So cosine, I don't know what this is. I'll put theta. You could put x also as a variable. It doesn't matter. Equals 7 adjacent over hypotenuse 9.
Is that cos?
Cos theta I put. But you could put x. It doesn't matter. It's just a variable. It's just a placeholder for a number you don't know. You can't put cosine theta. You can't put variables in the calculator. You could put x. You can't put an equal in the calculator. So what do we do to get rid of the cosine? Not really. Not really. Not really.
Cosine negative.
Good. We're going to use the inverse cosine. So I do cosine -1, which means I have to do it to both sides. So it's theta, or x, or whatever, is cosine -1 of 7, 9. To get rid of the cosine, you have to use this anti-cosine, or cosine -1.
So you're just doing this and
Then slap that in the calculator.
Divided by 738.
Yes, you have to show your setup. So I know what you typed in your calculator.
Second cos.
Is it 38.9?
38.9.
Cos. Wait, alright, 39.
Second cos.
Second cos.
Yeah, I did.
7 divided by
That's,
9.
yeah, and just 7.
39, 7.
What?
39, fine. Is it 38.9?
It should be 38.9. If you wrote 30, if you showed your work, I'll give you credit though. Okay. Oh, this is a good question. What does it mean to show work? I should see the setup right before you plug in your calculator. So I should see this.
Oh, okay.
Okay? I should see this. If you skip to that final part, I'm okay with that. But I should see what's before the calculator, right? Before you plug it in the calculator. AKA, I should see what you plugged in your calculator to make sense. If there's something goes wrong with your calculator, then I could check your work and be like, oh, the calculator's fault. And I won't take both points. That's why it's really important to show me. All right. This one is 12. We're looking at angle G. So angle G is opposite over... Oh, I'm sorry. What is 2 in this case?
Opposite. Opposite.
Yes, opposite from G. Good. What is 5 in this case?
Adjacent, so opposite over adjacent. So
Good.
tan.
Excellent. Because it's opposite or adjacent, we use TOA/tan. So tan. Theta, who knows what that is, equals opposite 2 over adjacent 5.
2 over 5, so 2 divided by 5. This is going to be 21.2.
Make sure you do tan -1. Yes, to get rid of this.
Wait, oh, it's -1?
Theta equals tan -1, 2 over 5. Let me just plug it in for the calculator or for the video.
What is your mom? Ethiopian?
21.8.
She's African, bro.
No, it's so safe yet.
How did you get the -1?
Second.
Second 10.
So you click the blue button first and it'll make all the negative versions. Okay?
This is 21.8.
Yes.
Yo, I'm actually understanding this.
All right.
This one's not that hard. Like, the other one.
Okay, last one.
Oh, wait, that was...
Yeah, this one's not that hard as long as you do tan -1 because you don't have to move any x or anything. You just type in tan -1 or whatever -1. All right, last one. I should have a little line here. My bad. All right. For this one is solving all the missing pieces. Now, on the last 2 years ago, I didn't have this correct, so I just reuse a couple of questions. So if you look similar, don't sweat it.
So 9 is height, right?
Okay, good. So you have to choose what you're going to find first. Let's find angle A first. Let's find angle A first. So this case,
90 already.
that's height. Yeah, you have 90, but 90 is like included. Everything has a 90 degree in this case. And this one is adjacent.
That makes it easier, though, huh?
Yeah, let's find the angle. So let's find angle A. So this is adjacent. This is hypotenuse. SOHCAHTOA. Adjacent hypotenuse. Ka. Yes. So cosine of theta, We could put even the letter A if you really want to.
Let's do X.
You could do X. Is 7 over 9? So how did I get rid of that cosine again?
Negative.
-1.
Good. Cosine -1. So now I have theta equals cosine -1. 7 over 9.
It's 38.9. We just did.
Good.
A.
That would be your A. 30. Was it?
So
38.9.
If there's like anything next to like the like post or whatever, then we do -1.
Alright, angle B.
If the variable, whether you put theta, you put X, you put A, it doesn't matter.
CB
But the
is-
variable in the cos, you have to use cos -1, yes. This being a variable causes you to do that.
7 over 9.
Or you could think of it, I'm looking for an angle. That's when I use -1.
Angle B is.
Yo, is it 38.94? Is that what the oh wait.
38.9. Let's just put 38.9.
Wait, for which one is that?
That's for A,
How do you know?
because we put theta at A.
Okay, and then angle B is opposite, so you gotta find I don't know.
You could do it like that, or make your life easier. Every triangle adds up to what in the inside? 180. This is 90, so you could take away 90. So what you could do is 90 minus 38.9.
You're not adding 38.9?
No, because I'm taking it away from 90. Because there's 90 left over, right?
But what angle are you trying to find BC? So is it which?
We're finding angle B. So we're going to do 90 minus 38.9. So 90.
Oh, I look, you just did like the whole thing.
I want you to know you are allowed to do that. You should get 51.1-ish.
I'm gonna check if I'm right.
That's for both.
That's for B. Doesn't matter if you do. You could do it also with sine. Like you could put your theta here and do sine.
Wait, how do you figure out CB?
CB, there's multiple ways. I could do it in a trig way, which in this case, if I know what A is,
B squared equals B squared.
you could also do it Pythagorean theorem. Let's do it one way as trig and one way with Pythagorean theorem. So with trig, I know this is 38.9. And I'm looking for this guy, BC. What's BC from A in this case? Opposite. What do you want to use, hypotenuse or adjacent?
Let's use a
Hypotenuse. So we have opposite, hypotenuse, SOHCAHTOA, that is so. So we could do sine of 38.9 equals x over 9 because opposite over hypotenuse.
9 times sine 38.9.
Good. So we're going to cross out the 9s. 9 times sine, 38.9. 5.6, 5.7 technically if you round it correctly. I will give you full credit if you round it even incorrectly.
Did I do like A squared equals B squared? So
Yes, you do. You should get 5 point.
Is it like, so for this, it would be like 7 squared?
In this case, I'll do it here.
X squared equals.
You'll say I'll do it. I'll do it here. So this one, you could say a squared because this is a side. This is a leg, not a hypotenuse. Plus 7 squared equals 9 squared.
Oh, yeah. Wait, so if I did 7 squared plus A squared equals 9 squared, doesn't matter, right?
Yeah, yeah. A and B could swap, but it cannot be C.
She doesn't like to see all
A squared equals, you're going to subtract 49 on both sides.
Right.
That would be 42.
And then the square root of 42.
Square root 42. 7 squared is 49. Square root 42.
6.4.
Oh, it's 32. That makes sense. Do I have an eraser here?
Oh, yeah, you might be right.
5.6. 5.65, 5.7.
That could be nice later.
I like that way more because
That's perfectly fine. It's 32, you're right. So square root both sides. A equals, very important. You'll see noticing this. You could find your answer in multiple roots. Okay? About 5.7. So,
it's 5.65, 5.7.
so rounds up to 5.7. And notice it should be the same answer either way. So, in this case, you could find multiple roots to the same answer, okay? Very important. All right, let's do the last one together. 14.
Let's do angle B.
Let's do angle B. If this is 63, then what would angle B have to be?
90 minus 63.
Awesome. What is that? 42. 57. 27. Okay, 27. Thank you. So 27, this is, oh wait, that's not the angle. That's 27 over here.
Hypotenuse, so 63 is theta, so like
I'll let you guys finish it off. How about that? Okay. Everyone, try yourself. There's multiple ways to do it. You go try this. Julia, Talia, try this problem. I'll be here. Okay. So let's do, because X is here, let's do X first. So this is a what to A? Let's see. What is this side? That's hypotenuse. And X is opposite, though. You're right. X is opposite. So which one uses opposite hypotenuse again? So let's do sine of, we know the angle, 63, equals X over 9.
Oh, it's not, wait, opposite of hypotenuse isn't co?
No.
It's so.
Wait, we can just cross it out now.
What do you mean?
Times 9.
Times 9.
It's 8 point,
So sin 63, that's it.
Sine 63.
So 9 times sine 63.
I'm so smart, it doesn't matter.
8.
That's AC?
Yeah, that's BC, so that's 8. 8.0 or 8. Because that's the opposite side.
Alright, so.
If I wanted to do the adjacent side, though, that would get me AC.
So how do you do?
So in this case, it would be cosine 63 equals X over 9.
Can you do that? It's 4.
Wait,
4.1.
no, you can't do it.
4.1 I think is AC.
Let's see. 9 times cosine 63. So in this case, you're using cosine. Changes the question. It is 4. So 4.01 or 4.1.
Yeah, you got around that.
4.1. Yeah, 4.1. Yep. What? AC? I did 9 times cosine 63. Because from A, adjacent and hypotenuse would mean cot.
What?
All right, chill here. I'm going to print out more.